Hello, happy Sunday. Oops, happy whatever day. Yeah, why am I holding a fork in my hand today? Well, because in the morning I had pancakes. I love pancakes, and I'm actually making the video right after eating pancakes. So I'm full of energy and enthusiasm. Uh, so, what are we going to do today? Well, this week is going to be all about coding. Okay. Last week we talked about k-means clustering, and this week we are going to be talking about coding. How do you actually code that in? And I think most of you know that most of my courses actually run on Python, and I love the Python programming language. Why is it that I love the Python programming language? Well, there are n number of reasons. It's a very expressive language, and there are so many libraries. But those are not the reasons why I chose to code in Python. So, can I share my own story with you? Well, I started programming, or I started to try to learn programming like 15 or 20 years back when I was in my college. And I started off doing C programming, okay, thinking that C is the best programming language. And I learned C programming for 5 days, okay, 5 days. And then I dropped off. It was too much for me. And then a few years later, somebody told me that you should try Perl programming language together with R, statistical programming language. I said, okay, that looks like a good suggestion. And I applied myself to learning R and Perl programming language. This went on for 5 weeks instead of 5 days. And after 5 weeks, I lost interest and I just, said, I'm not going to do this anymore. This went on, and later on I had to learn some programming language because I was doing a lot of coding and computations. So after a year or so, somebody suggested Python, and then I switched to Python, and it's been like more than 5 years instead of 5 days or 5 weeks, and I'm still going strong in Python. It was like a breath of fresh air. Why? Because I love English, and Python is almost like English. So the learning curve is like super flat. It's not steep like with other languages, and you can do a lot of things with Python. Okay, so this coding exercise is not my own. I found it on the web. Unfortunately, I cannot recall where I found it, but I have modified it a lot, and I want to make sure that you understand each and every line of code that is presented in this notebook. And I'm not going to do a long video talking about how to go from reading the data in all the way to getting the results of k-means clustering and evaluating it, but rather we are going to divide it into 3 videos, okay? This is what I usually do when I have a big task. I divide it into different pieces. And after I complete the first part of the notebook, we are going to talk again. There will be a short introduction to the second part of the notebook. And then after you're done with the second part of the notebook, there'll be a third short introductory video for the third part of the notebook. But if you have any comments, please feel free to write them either in this channel or you can email me. Either is fine. So get ready and fire up your Jupyter notebook and get ready to code. See you after you are done with the first part of this video series. Today, someone saw me doing this recording, and the screen's in front of me and the laptop in front of me, and they were kind of convinced that I'm not quite all right in my mind. I wouldn't kind of blame them, would you? I have these laptops in front of me and there's a mic in front of me, and I am talking to the mic and doing something on the laptop. Well, apart from that, let's get ready to dive into the coding notebooks for k-means clustering. And are you ready for this? You have to say, I am ready. So here we go. We are going to open up a new Python notebook. And we are all familiar with the Anaconda interface or the Jupyter Notebook interface. What is the very first thing we need to do? Well, the very first thing we need to do is we need to know how to be smart and where to be smart. So we are not going to write code that somebody else has already written, right? Why reinvent the wheel all over again? So here we are going to import all the modules. So module import is going to be the first step, okay? and I am going to convert that into a heading. I'm going to hit run, and every time the cell runs successfully, we say yay. Get ready to say yay. So the very first module, my favorite module, my all-time favorite module if you are doing data science, is pandas, right? So import pandas as PD, right? Why? Well, because you have to be able to read the data in and do things to the data. And as you know, pandas is one of the best Python modules out there to actually do this. And because we'll be doing some numerical computations, I'm going to import the numerical Python library, numpy, and I'm going to call it np, right? I like to shorten module names. Actually, I'm not the one who's shortening the module names. These are like standard conventions, but you can call them, if you want to call them something else, you can, okay? Then import matplotlib.pyplot as plt. Now, why are we doing this? Well, we are going to be making some visualizations or plots, and we need to be able to control those plots. You don't really like this line that goes there. You don't want to change that line. You don't really like blue color, and you want to convert those into red colored lines. You can do all that with matplotlib, but we are not going to be directly interacting with matplotlib. Why? Well, it takes a lot of code, okay? To just draw a simple plot, you need to write a lot of code. Instead, I love this package called Seaborn. Import Seaborn as SNS. Now, what is so cool about Seaborn? Now, here's the secret, okay? And what is the secret? Well, we are actually going to go to the Seaborn website. Okay, I'm going to Google for it. Please stay tuned and be with me here. Seaborn. Okay, statistical data visualization. And what is so cool and what is the secret is that, did you see this gallery, the Seaborn gallery? And if you go there, you can actually see a beautiful set of data plots. Oh no, you may be asking, that is cool, but it's not a secret. What's the big secret here? So, okay. So for your data, just pick a plot that you would like. Okay. For me, this snaky kind of a plot looks really attractive. Okay, so I'm gonna click on that. And this is not the secret, okay? The secret is this, okay? If you like this plot, what you have to do is, you don't have to write code. See this code here? So you're just gonna copy that and then paste it into your notebook and then just massage parts of the code, and just change the data. But this is not the data that you are using, right? So change the path to the data, and then you can go ahead and make these visualizations in no time. So that is a little secret that I wanted to share with you. So let's go back to the notebook. So that's why I like Seaborn, and I like to call it SNS like most other people do. What else do we need? We need to import the date time module of Python, and we're going to call it as DT. Okay. And then from Scikit-learn dot preprocessing import standard scalar. I know that some of you can type really, really fast and really, really quickly. It's the same thing, right? I know that some of you can type really fast, and I am like a slow at this. So, I mean, if you really think that it takes a lot of time, what you can do is you can just go ahead and view this at 1.5x or 2x speed, okay? But for the rest of us, who like to do things slowly, one thing at a time, please follow me, okay? Now, from Scikit-learn dot cluster, and Scikit-learn, by the way, stands for Scikit-learn. You know Scikit-learn, right? It's one of the most popular libraries for machine learning, especially in the Python world. Import, well, what are we going to do? K-means, right? We are going to do K-means clustering. Now, we want to not only just do the clustering, but we are actually going to see if we can measure the performance of the model. How can you measure the performance of an unsupervised model? Well, there are a few methods. None of them are set in stone. and it's not nearly as straightforward or clear-cut as with supervised learning, but we will examine a couple methods. So from Scikit-learn.metrics, import, there's something called sillout score. We'll explain that when we do the coding. Sillout samples and sillout sillout. See, I'm getting the spellings wrong. Sillout a score. Okay, and this is a secret. We'll see what this does. Okay, import matplotlib.cm as cm. Okay, and finally, because you want all these plots or these data visualizations to show up inside your notebook, we are going to say matplotlib. See, typos, matplotlib inline. So did you know what happened? The first time I was teaching a class in the US, I really wanted to do this live coding, and I made a big announcement saying that, hey guys, we are going to do this live coding together. Everyone, please, you have your computers open. And this was at a company, okay, and I was like coaching people at the company, and they all had their computers ready. And when I started to run the code, it broke down. Okay, so that was a big letdown. And but what I did was I said I need a coffee break. I'm not feeling so well, so I took 5 minutes off. Did not have coffee. What I did was I quickly Googled for help, and then I got help and I fixed it, and I came back. So if you hear me saying that I need a coffee break, then what that means is something is not working on Ram's computer. So Ram is going to use Google and fix it. Okay. So here we go. Now keep your fingers crossed. This is really important because we are going to run the code. Okay. 3, 2, 1, 0. It did run. Yay! Say yay! All right. So what's up? What's next? So we actually want to know where we are actually. Okay. So I'm going to do this. This is your Unix command, right? So this is where we are. So I'm calling this folder info7390 reloaded. Why? Because I taught info7390 for Spring, and this is like reloaded. Much better, actually. It gets better and better. And what else do we need? So one thing we need is data. We need data for this exercise, so for sure. And for that, I actually want to know where the data is. So one way to do that is to list all the files in that folder. And there's so many stuff. And did you see this online retail.xlsx? Now that is the file that contains the data that we are going to use to do k-means clustering. All right, so what else? And if you want to know more about the data, I can actually point you to a website. That's where I got that from. It's not my data for sure, but I am actually going to read the data in. So df equals, I'm making a variable name, pandas dot. Now, if you are not sure what are all the things that pandas has, or what are all the capabilities that pandas has, inside of a Jupyter notebook, if you put a dot right next to it and hit the tab key, you will see the menu coming up, just like you go to a restaurant and ask the waiter for a menu, right? The waiter or the waitress. And this is how you ask Jupyter Notebook and Python for the menu. Okay, why? Because everything in Python is an object, and if you put a dot right next to an object, and if it's inside of this Jupyter Notebook, then if the object is active, what happens is you will get the menu of all the things that you can get from that object and all the things that you can do to that object. Okay, so pd dot, because this is an Excel file, right? I'm going to do read Excel. Where is, what is the path? The path is this. Copy, do that, and do that, and this is the file we are interested in. Okay, so I'm going to do that and put them inside quotes because that is how you specify a path. And once you run that, we'll see what happens. Fingers crossed. Fingers crossed again. More tightly. It's running. It looks like it's a pretty large file. That's why it's taking a lot of time. Okay. Please verify for yourself that you had that file downloaded. So let's talk about something else while Pandas is reading files in. And did you know that now Python has another package called Numba, Numba, that is like lightning fast with numerical computations. Okay, so those of you who are really looking to speed up their numerical computations, you can use things like Numba, which is a pretty useful Pythonic thing to speed up your numerical computations. The other package that some of you might be interested in is not even another package, it's another language. So, I mean, I sometimes hear these questions from students saying that, hey, I don't know if I'm really into Python that much. Ram seems to like Python so much, but I'm not sure if I really like Python that much. Can we have another language that is as powerful as Python, but which is not like, Java or C++, but is almost as easy as Python, but I still can do a lot of data science with it? Well, that language is called Julia, okay, Julia. But see, I mean, our code has run, so I'm going to say yay, right? Now, df contains this data frame. The data frame actually contains data from this online retail sales. Now you can ask the question, hey Ram, did you actually read it in, or are you just doing some thing, and how do I know that you have read the data in? Well, do not trust me, do not believe anyone in data science, just believe the data itself. So what I would do is print df dot shape. That'll tell you the shape of the data frame. What do I mean by the shape of the data frame? How many rows it has and how many columns it has, right? Simple basic stuff. And then df dot head. Now why the head? Well, everything in Pandas, and it's Python, right? Python is a snake. So the head means the top 3 rows, or the 5 rows actually. By default it is set as 5 rows, but I don't want to look at 5 rows. I'm only going to take a look at the tip of the snake's head, which is like 3 rows, okay? Now fingers crossed, and I'm going to hit run. Yay! We ran that piece of code. And let's see how many, this is the shape of the data frame, right? 541909 is almost like 500,000, almost like 5.5 thousand rows of data. And this is the number of columns. There are 8 columns for the data, and these are the columns. Okay. Now, one thing that immediately jumps out at you when you look at this, and you take a sneak peek, or you look at the head of the snake, or not the snake, the data frame, is what are the kinds of things that are in the data frame? What are the kinds of things in the data frame? Well, these are like invoice number and stock code. Those are like identifiers, okay? These numbers cannot be added together for sure, okay? Because they are identifiers. You cannot add your home address to another person's home address, right? That makes no sense. And then you have these strings, right? These strings. And then you have these quantity, which are numbers. These things can be added together. It's meaningful to add them together or subtract them or whatever. And then you have date. Okay, this is called date. And then you have another numerical variable. And then the customer ID, those are categorical variables like these. You cannot add them together. And the country, again, another categorical variable, right? Now, the other thing that I'm going to talk to you about is something that is universally true across data science, is we are yet to invent an algorithm, okay, or a machine learning algorithm to be more specific, that can directly compute on non-numerical data, which means that any kind of data that looks like this, white hanging heart, tea light holder, I don't even know what that is, but anyway, this is some kind of an item that was sold for this unit price, just got bought by this customer in United Kingdom. So all these things needs to be converted into numbers, and we will see how they can be converted into numbers, okay? And the other thing I want to know is, okay, so this is what I see, but I now want to know what the computer sees. So df.info, that gives you, fingers crossed, yay, that tells you what are the types of things in each column, okay? So most of these are objects. This is int64, means it's an integer 64, datetime 64, float 64, float 64, blah, blah, blah. Okay. Now, I hope we are all good so far. If something is not working, just email me or the TAs and we'll see what we can do. So the next thing we are going to do is we are going to see how many null values there are. What are null values? Well, you might have heard of these before, right? There are some places in this data frame where there's a hole, okay, which means that there's no data. It's not equal to 0. If we have a 0 popping up here, then it's not a null value. It is a value. It's equal to 0. But many data frames contain these null values, okay? So null values are holes, and again, as with non-numerical data, we are yet to come up with a machine learning algorithm that can compute on these holes. So we need to fill those holes or throw those holes away. Let's see how we can kind of pursue this. Okay, so we are going to calculate what fraction or what percentage of each column is actually made up of holes in this data. And how do we do that? This is how we do that. So null values equals, you can use your own names for these variables. And there is another secret I'm going to tell you. Now, I am not this super genius who can simply code things up without looking at anything. I have another laptop to my right, and the code is already there, okay? So I'm actually looking at the code and typing things in. Trick you. So df dot is null actually checks for null values, dot sum, right? Because you want to know how many null values are there for each column, and divided by the length of the data frame, okay? Len of the data frame, well, that's because we are interested in the fraction of all the values that are null, times 100, okay? Because we want to convert it into a percentage. And now null vals equals pd dot data frame null vals. Why? Because this null vals after this line is executed is not a data frame. I'm converting that into data frame. One thing you can do is you can combine these two lines of code into just one line of code, okay? The code that I'm writing is not the most efficient way to write code. In fact, if software engineers were to look at my code, they will kind of kick me out. But I just want to make everything so explicit, okay? Because we are just learning and having fun with data science, so who cares? Now, null vals dot reset index in place equals true. Why are we even doing that? Well, I'm not going to talk to you or give you the details for every single line of Python code we are writing, but I'm just going to make some broad comments. Well, we are just kind of resetting the index because this thing kind of creates weird indices, okay? Now, null vals dot columns equals feature. I'm just renaming the columns. Percent missing. I like to have these nice names. Big fan of names. plt dot figure. That sets the figure size. To set the figure size, you can do a bunch of other things while you are making the figures, like changing the tick marks along the axis, changing the background of the figure, etc., etc. And I'm going to do another one. plt dot xdix. Okay, xdix rotation equals 45. I want the xdix at a 45-degree angle, and then I'm going to make a bar plot. So sns dot hit the tab key, and did you see the bar plot? Yes. And if you want to know what are all the things that will go in, or the parameters, just hit shift tab and you will see an extensive list of all the parameters, okay, here. So just in case you are wondering, but I have to specify what has to be plotted on the x-axis. So on the x-axis, I'm going to plot percent missing. Okay, percent missing. Oops. I know I'm pretty slow, right? So please kind of, do 1.5x if you think that this is super slow. But this is as fast as I can code. Thankfully, all my employers do not look at how fast I code. Otherwise, I would have lost my job a long time ago. Okay. All right. So, fingers crossed. Hope there are no typos. Hit run. There are typos. Name null vals is not defined because I made a typo. Yay! Null typo. Change that. Okay, no more typos. Yay! All right. So this is what you get. And this tells you that out of these 8 columns, the customer ID column has a lot of null values. Okay, it's like, this is like 25% because we are plotting the percent missing on the x-axis. Almost 25% null values for the customer ID, and the description column has a little bit of null values, maybe like 1% or something, maybe less than that. Looks like, look carefully if you can see any color anywhere. Nope. And if you can't trust your eyes, what you can do is you just print out the table as such. Okay, look at the numbers instead of plotting them and looking at it. But when you are showing your work to your manager or to other people, the best way to do this is to convert or change all your tables into plots. People love plots for some weird reason. Anyway, so that's where we are. We have actually gone from reading the data in to visualizing all the null values. Let's do a little bit more, okay? And then after we are done with pre-processing the data, we will actually take a break and we will see in the next video. But so what are we going to do now? We are going to drop rows with null values. Okay, we are going to drop all the rows of data with null values in either of these 2 columns. So how to do that? So I'm going to create a new data frame equals df dot drop na. What are we going to drop? Well, I'm going to subset it equals customer ID, right? Customer ID. This guy has a lot of null values. So we're going to drop all the rows of data where in the customer ID field there are null values, and also in the description field. Why? Because the description field also has a few null values. And now I'm going to check, print out the df.shape. That is the original data frame. And I'm also going to print out df1.shape, okay, to see how many rows of data we lost. Uh-oh, it's not dh, it's df. Another typo. I didn't cross my fingers. No wonder. Cross my fingers. Yay. We won. So did you see that almost, how many rows of data did we lose? That was 541909 in the original data set. And when we kind of dropped all the rows containing some null values, we have now 406829 rows of data, which means we lost almost 141,000 rows of data. That's okay. We still have this much. Otherwise, the other way to treat this was to impute the null values. Okay. It's a little bit challenging because these are customer IDs. It's not easy to impute. Or what do you mean by impute? We are just filling up those holes with numbers, your best guess for those values. It's really hard to do that with customer IDs. So we are not going to do that. We are simply dropping the rows that contain these null values. Okay. Now, the other thing that you may see is in these kinds of data sets is there might be duplicated rows. So you want to make sure that the data that you pass to the machine learning model, whether it be supervised or unsupervised, does not have duplicate rows. It's a good practice. So you're learning all the good data science practices. So I'm going to create another data frame, df2 equals df1 dot drop duplicates. So this is an inbuilt pandas function, so you don't have to do anything much. And then, as with before, I want to look at the shape of df2 to see how many more rows of data did we lose. If your pre-processing is too stringent, sometimes you may end up with 0 rows of data, and then there won't be any data science. But anyway, okay, so I'm going to hit run. Keep your fingers crossed. Yay. So we lost just a little bit of data, right? I mean, we went from 406829 rows of data, and when we removed the duplicates, we ended up with 401604 rows of data. which means that there were like very less duplicates, something like 5,000 rows of data. Yeah, those rows of data were duplicated. So there were duplicates, but again, those were not like super large, or they did not become a large proportion of all the rows. So I hope you followed this coding video so far, and as with any good things, all good things come to an end. So I'm going to stop the video now, and let's meet each other in the next video. Why? I need a break. I want to drink some coffee, and I'll be back. So watch out for the next video. And as it's true that all good things come to an end, it's also true that new good things must start too. So wait for those new good things, which means my next video on where do we go from here. Okay, now we have kind of pre-processed the data, and the next video we are going to go from pre-processing all the way to doing actual k-means clustering. Okay, did I get you excited? Yay! All right, bye bye.